It's possible that a doctor give you problem that you are pregnant, but actually it's not. Or opposite, you are not pregnant, but actually you are pregnant. This is the same as you have cancer, but the doctor make mistake. The doctor said you don't have cancer. Or the opposite, you actually have no cancer, you are healthy, but the doctor make mistake that you have cancer. So these two things are different. This is called false positive or false alarm. This is called false negative. And let me tell you a funny story. The 1983 Soviet nuclear false alarm. In the Soviet Union, they have some people watching the monitor, see whether or not the US fire missile to hit Russia. And then one day, there's a guy sitting in the room, and then he watched the monitor, see something that looks like a missile flying into Russia. At that moment, if he told to his upper body, then probably the upper body will press the button, nuke the US, and then World War III. That means we may not even exist. That person decided that it is a false alarm and world peace. I'm very sure the probability that you know this happened before I told you is very low. Okay, this is also a conditional probability. Okay, now you know. Okay, if you want to know more about this, Google this thing. Okay, another thing is, now we have what? ChatGPT, LLM, and if you type up something, usually they make up bullshit. This is what? This exactly is false positive. It's like what? It's like doctor said you have cancer, but actually you don't have cancer. This is bad. But at the same time, if you have cancer, but the doctor says that actually you don't have cancer, this is also bad. So in statistics, they call it type 1 or type 2 error, which is a stupid name in my opinion. Just call it false positive and false negative. So this is funny. You have two choices. You don't study, or you study. So hard is false, hard is true. And then good grade or bad grade. So for example, good grade and bad grade. So you have 4 numbers. Of course, this is what we want. Everybody want. Okay, so this is good, right? If you study hard, supposedly you should get good grade. What about this? You study hard, you still get very bad grade. Bad, sad. This one, you don't study, you get good grade. You don't said, I said. Okay? What about this? You don't study, you get bad grade. Okay, normal. So basically, these two, okay. These two, okay. What about these two? These two actually fight against each other. Why? Suppose I make the exam paper very difficult, then even if you study hard, you fail. Okay? But if I make the exam paper extremely easy, then you don't study, you get good grade. So, you see, if I tune the exam paper, suppose exam paper have a number, think of it like playing computer game, you have a boss to fight, and if I make the difficulty level higher, then more likely you go to here. If I make the difficulty lower, then more likely you go here. But the reality is both of them are bad. I want to make a number such that this is small and this is small at the same time. So that's exactly what is machine learning, what statistics is doing. Try to find a way to make these two numbers occur as low as possible. These two black ones are good, so we don't care. That's it. We now go to the descriptive statistic. What the heck? It's basically these two things. Okay? Mean and variance. You may not know what the heck is this. Now I'm talking about this. So if I pick all of you and then measure your body height, very likely the distribution or the height will be something like this. That means what? Most of you will be around the middle of some height. I don't know the exact number. Very few of you extremely short and very few of you extremely tall. This is called normal distribution because this is so normal, or you call it Gaussian distribution. But actually, this is not a full story. For example, if I pick a bunch of people from the Netherlands men's volleyball team, okay, Netherlands volleyball team, all of them are super tall, but they still also have this, right? That means then what I will get? I will probably get a distribution that looks like this. Okay, that means what? It's also normal distributed because I just randomly pick from the Netherlands. But I pick from the Netherlands volleyball team. So their shape will not look like this. Then we call it skewed because it's not symmetric. It's skewed towards one part. Okay, lastly, what about this tailoredness? So suppose I again pick the Netherlands volleyball team in the Olympic. Okay, I'm not saying volleyball team. I'm saying the specific group of people that they went to the Olympic. Then the Netherlands country will say that no, we will pick the best of the best, tall of the tall. Then what? They are not going to allow any one of them shorter than 2 meters, let's say. Then they probably will have this kind of thing. Okay, that means what? Before 2 meters, absolute zero. So you see, this is different because here I have some tail. This is called tail. If I have no tail, then this is called kurtosis. Okay, these are new for you, but again, not in exam. I just let you know this exists. If you study these two and then you think that, oh, now I have enough statistics and I can use it in the real world. No. The reason why it's not enough because you have these two things. This actually is called first order statistic. This is called second order statistic. This is called third order statistic. And this is called fourth order statistic. A bunch of them again. So we don't care about this, okay? We just call about probability mass function, PMF. What the heck is this? Very simple. People are lazy. We just write this. Yeah, no longer write this long symbol. Suppose I have a function, which the technical name is called PMF, with this 1, 2, 3, 4, 5 up to 12. This is sample space, and the probability is this. So what is this? This is 12-sided dice. You have a 12-sided die, which is some dodecahedron thing that I don't know how to draw. Okay, you have 1 to 12, and I toss it. Now I have this funny thing. Find the probability that 3 times the outcome minus 4 is between 2 times the outcome plus 7 and outcome plus 2. Okay, first of all, nobody will do this in real life. This is just mathematics, okay? Then how do you solve it? Very simple, it's just math. So, I want to find this P, right? The idea is I want to make the middle guy become X. I just want to make the middle guy become X in the end, okay? So, what I do? I need to kill stuff. So, I subtract X. This is what I do. First step, I subtract X. I do everything here. Subtract X, subtract X, subtract X. Now, this term have no X. There's only a 2 here. Good. So, this part have no variable, random variable. Good. This part, 2X subtract X become what? X. So, I have this. The middle guy, 3x minus x is 2x. And then what? I plus 4. So I plus 4. So this part plus 4, this part plus 4, this part plus 4. Okay. Number 6. This one 11. So now I have this. Okay. What's next? This one is funny. You see what I'm doing? I subtract x. And then what? This one easy. No x. Gone. This one x is gone. But this becomes 3. Why? Think about it. And then I get this. Suppose I get this. Then what is this? This means I have x is 1, 2, 3, 4, 5, 6, blah, blah, blah. But it says between 3 and 11. So it's here to here. Then I have this thing, right? Then each of them, what's probability? Okay, I don't want to go back to the very beginning. Classical definition of probability is what? It's the size of the event divided by the size of sample space. What's the size of sample space? 1 to 11, right? Or 12. Okay, so 12. What's the size of the event? How big is this set? 4 to 11, 8 number. So 8 divided by 11, 2/3. So therefore, this thing is equal to this thing, is equal to this thing, is equal to this thing. So now I'm going to explain what the heck is a 3. So this line is the same as, right? Then, okay, this. Then this become, so now you see how I get this x3, right? Do not underestimate this. You may think that, oh, this is just I minus x, and then I minus x, and then I minus x. Then where is the x? Why 6 become 3? No, this is 2 expression. So this is the first expression. I divide by 2, so I get this. This is second expression. I minus x, so I get this. You see? So this is why you get 3. So this is exactly what I just said. So now I get this. So basically the idea is, with this in mind, if I can write down everything as a probability mass function, which is basically a function, now I can have any way I can find a probability. So it can be like this. What? I have x represent a dice that is 6-sided. I have a y represent a dice that is 4-sided. What's the probability? Let's say I toss these 2 dice and you also toss these 2 dice. What's the probability? My value is always larger than you by 1. That means 2 players. One is me and one is you. We both toss dice. We toss the same thing. One 6-sided and one 4-sided. And I want to find the following probability. I don't care what's the outcome. I want the probability that my number, outcome, add together, always larger than you by 1. Then you do this with xy. And then with this, now we can do something called average, mean, or expected value. So we write this symbol, EX. Ignore this. For all the possible small x, you multiply the corresponding probability and you sum all of them. So here's an example. Suppose I have like this. So first, what is the sample space? Look at what's possible for x. It's 1, 2, 3. So 1, 2, 3. What's this? The probability if x is 1 is half. The probability of x is 2 is 0.4. The probability x is 3 is 0.1. What is EX? All the small x times their probability. So when small x is 1 times the probability x is 1, half. Small x is 2 times the probability x is 2, 2 times 0.4. Small x is 3 times the probability x is 3, 3 times 0.1. And then this symbol means add all of them. Add all of them. So this is a number. So that means this is something like I have a 3-sided die, which is some board. Okay, you imagine I have a board that draws something like this. I have 3 sides. One is 1, one is 2, one is 3. And then what? In this board, there are some solid stored inside. So it's more heavy in 1, less heavy in 3. So have higher chance when you toss it, one will go on the top. You can think of it like this. Then I'm asking you, if I toss this ball, what's the average outcome? It will be 1.6. This one, ignore it. This is Gaussian distribution. I assume you don't know what the heck is this, so no. Okay. You have 106 person, and then this is the number. And then what? Find the average. So first you need to find a sample space. Important. Previously, you may think that, oh, sample space is just 1, 2, 3, 4, 5. No, you see now there's no 1, there's no 3, there's no 5. All the sample space, due to some reason, is even number. So therefore, sample space is problem dependent. That means this is impossible event. Now I have a table. Why? This is not probability. Because sum of omega, that means the probability of omega is not 1. This value is very larger than 1. So I make like this. Now the probability, that means all the things add up together in a sample space is 1. This fulfills definition of probability. Now a sample mean. All the possible x multiply their occurrence chance and add up together. 0 multiply this, so this 2 multiply, plus this 2 multiply, this 1, plus this 2 multiply, and so on. This. So what does it mean? It means based on this table, on average, 1 year we will see 3 ill people. That's it. Important. Sample mean is not expectation. What does it mean? You see, I don't write down the E symbol here. Sample mean is a way to estimate expectation. Here's the idea. This is saying that you draw 100 people random and you get this number. But it's possible you draw all these 100 people in one specific place in the world and you forget other places. Then this is a bad estimation. So this is important. So sample, which I write a bar, and EX are not the same thing. And in statistical analysis, basically the idea is I want to do this. Find the probability that my sample, that is I have a bar, difference to the true value of a X absolute value smaller than a very small value is going to 0. What does it mean? This is an estimation obtained by doing experiment. What is this? This is the true average value of something. What is the subtraction? Their difference. What is this absolute value? This absolute value means I don't care which one is bigger. I just want to care about their distance. What does this smaller than epsilon mean? This smaller than epsilon tell me how accurate is this precision. If this is very small number, means these two have a very close to each other, the value. And what is this P? I want this thing to happen very close to 0. Sorry, 1. I made a mistake. Yeah. So I want this to very close to 1. That means what? I want my estimation when I do experiment, the outcome close to this value under the precision here, very high chance. For example, we want to know how many atoms in the sun. Then you do some experiment to find this. We can never know this because this is the true number of atoms in the sun, right? How do we know how many atoms in the sun? You go inside the sun, but we will die. So this is something that we can never know. So what we do, we want to find an estimation of this thing, which is question mark. What we do, we have no way to get this because this is a question mark. So we do it indirectly by saying this. What is this? It means the probability that my estimation very close to the true number is very high. And because of this reason, that's why this thing is not this thing. In the technical writing, we say this thing is approximately this thing. So this is the difference. Sometimes you may see that the Department of Mathematics and the Department of Statistics, they split out because mathematics write equal sign. They require absolute equal. Statistics say that we don't do this. The statistic equal mean this. The probability that something is true is high. So these two are different things. That's why I said sample mean is not expectation. Here's another example. I have this data. I have a sample space. I have a sample mean. Now I'm doing this. What is the probability? I select this random 100 person. I select one. And this person have more than 3.08 seizure a year. Then it's the same. I find a probability that X larger than this number. This number is an average. Then you do this. This is 0.45. That means you randomly pick a person. Almost half the chance, this person will have more than average number of seizure. Now this. Okay, this is exactly what I said. Find the probability that X minus X bar absolutely very larger than 1. What does it mean? It means, what is X bar? On average, how many seizure a year? What is X? Random variable. What is the absolute value? The distance between the random variable to the average number. What's larger than 1? Your X is very far away from the average. What's the probability? How likely is this thing? So, if I have this means what? Well, on average, you have 3 seizure. So, no seizure is very far away from 3 seizure. 8 seizure is very far away from 3 seizure. So, 0 and 8 is also there. But how do we call far away? I said far away means larger than 1. So, 2, 6 is also far away. 2 seizure to 3 seizure is distance is 1.08, slightly above 1. So, it is defined as far. So, I count here. 6 seizure to 3 seizure, of course, far away. So, I have here. So, I have this. It's the same as I just ignore 4. So, the chance is 0.28. That means what? That means actually if I randomly pick somebody here, the chance he have the number of seizure he had that is very far away from the average number actually is quite high. So that means what? That means only these few people will have the seizure that is close to average. Other people are actually very far away. That means what? This distribution means many people in this are in the extreme case. Lastly, what is this? This means distance between X and X bar smaller than 2. That means what? I describe how far away is X to the average value by 2. If the distance between x and 3 is within 2, I say they are close together. So it will be what? 2, 4. Because 2 and 3.8 is below 2, the distance. 4 and 3.8, the distance is 1, so smaller than 2. 6 is not. So how many people will have amount of seizure this close to the average is 0.39. Next one, if I put an f here, f mean function, I can do the same thing. Suppose I have this random variable, the expected value, I just do it like this, but now I put an f here. Then the small x, previously have no f, now I have an f. So suppose I want to do this, log x, so I do the same thing. And this thing actually has a name called maximum log likelihood estimator, which is exactly what machine learning is doing. Again, not in exam, I just let you know. Then you may wonder, what the heck, why doing this? So here's the thing. Suppose I have a dice, 1 to 6. So expected value of dice is 3.5, right? But suppose you're now playing a D&D, the game master is very good. This term, all your number double. So not 1 to 6, now it's 2 to 12. Find the expected value. How do you find it? You just multiply all this by 2 and you calculate this again. The multiply by 2 is exactly the f here. Or you can say, in this term of game, the game master said, due to your poison, all the values subtract by 2. Then what you do? You don't have 1 to 6. You now have negative 1 to 4. Then this subtract by 2 is this f. So basically means from our sample space omega, we do some trick. We call f, which is a function. And now we calculate a new x. Okay, here's another example. I have a 4-sided die. I toss it 1, but now I find ex squared. So that means what? All the output I get, I square it. Then I will have this. This is what? This is not xpx, this is x squared px. What is the square? Square is the f. Okay? The f here is a square. Then I just do this. What does this mean? This means outcome is 1. I square it, doing the f, multiply the chance of seeing 1. What is this? Outcome is 3. I do the f, which is square, multiply the chance seeing 3, and I do this, I get this 7.5. And then, now you will see the first law of expectation is linear. Oh my gosh, what the heck? Let's do it one by one. If I have a random variable x, and I have a random variable y, I scale it by a, and I scale it this by b, and I plus c. This actually is called linear equation. It's the same as I do this on each x and y, and then I do the scaling and addition later. This is the same as I can put this inside, and that's it. This thing is a e of a f, this thing, right? I just show you what is e of f something. You put a f on the bracketed thing. So I have a f this thing. This f is a bracketed thing of 2 things. Then of course f here I have a bracketed thing of 2 things. Then what? What is this f? This f is ax plus b, y plus c. Then I just put down here. What's next? Now, this thing, I can just math. I put this inside, put this inside, put this inside. So axp, byp, and cp. Okay, I have this thing. So I just expand this bracket. And then what? Summation side, I can go inside, right? So I put the summation side into each term. And I can also take out the scaling factor. So I have this. And then what? This is summation side with double symbol. So I write them double. And then what? This thing, I have an x. This summation side is on y. Nothing to do. I can take this out. I put it here. This thing is on y. This thing is on y. Okay. But this thing is on what? Nothing. So I put it here. Lastly, this guy have what? This is all the xy in the sample space. By definition, the probability of sample space is 1. So this whole thing is 1. So that's why I have a c times 1. So it's c. So now I have this thing. Okay. What is this? This thing, this small p is exactly this big P, just lazy notation, okay? So I have this small p is just this big P, lazy notation. I just write down the lazy notation. And what is this part? Marginal probability. So I can now write this part. What is this part? Marginal probability on x. This means all the x I sum, I don't care x, so I get y. Okay? Now what is this? This is just xpx. What is this? This is just ypy. This is exactly ex and this is exactly ey. All of them are equal. So this thing equal here. So this line is true. What I did, I just rearranged term, use the old stuff. So this is true. Okay. Another thing, x, y are independent. Then their expected value are also independent. And I can split like this. This is the proof. I don't talk about the proof now because I'm not going to test you proof. So here's the example. This is why this is useful. Suppose I have to toss a 6-sided die and a 4-sided die. All of them are fair. So x is a 4-sided die. Y is fair 6-sided dice. I want to see the outcome. You have many ways to solve it. The first way or the best way is to use the thing I just told you. In this case, A is 1, B is 1, C is 0. So I have ex plus y equal ex plus ey. That's it. This is the first way. What's the second way? The second way is you find all the possible outcome of x and y, and find all the possible probability and then compute them and then do a shit ton of things and you get the number. But if you use this formula, 19. This is why this is useful. Okay, so let's look at them both. So method 1, use shortcut. Method 2, use definition, which is insane. Method 1 is this, right? So EX plus Y is EX plus EY. What's EX? X is 4-sided die. What is the average value of 4-sided die? 1, 2, 3, 4 divided by 4. Yeah. What's the average value of 6-sided die? 1, 2, 3, 4, 5, 6 divided by 6. Done. No workload. Now let's go about definition, the stupid way. I want to find this. So I now create a new random variable called S. This S stands for sum. Sum is X plus Y. What's the probability? We first need to know what is sample space. So first we need to know what is sample space. Notice that we know the sample space of Cartesian product, not the sample space of the sum. The sample space of the Cartesian product is this, right? But the sample space of the sum is this. You see, these two things are not the same thing. This means X is 1, Y is 1. This means X is 3, Y is 4. X is 4, Y is 4. This means what? This means S is 2, S is 3, S is 4, S is 5, S is 9, S is 10. Not the same thing. And then what? You also the probability, right? You see this case with 1 over 24 chance. You see this case with 1 over 24 chance. What about this? You also have the same probability. Then what? For this probability random variable S, the sample space is 2, 3, 4 up to 10. You calculate all the possible cases here, and then you look at how many times it appear. This appear 1 time, so chance 1 over 24. This 3 appear 2 times, so 2 over 24. This 7 appear 4 times, so 4 over 24. So now you have this random variable. Lastly, how do you calculate this? You calculate each of the S, multiply each of the P. You do this, and you give you 6. You see, this is a lot of work. If I use formula, 19. If I don't use formula, I do this. That's why this slide is super powerful. And what? If you figure out some random variable independent, you can skip a lot of things. Otherwise, you have to do something like this. Okay, so here's an exercise. X is random variable of tossing a fair 2-sided die. That means output is 1 and 2. Y is random variable tossing a fair 4-sided die. 1, 2, 3, 4. I want this funny value. X minus 2y and then square. Find the average value. Solution here. Dude, okay, I'm not sure. Now break.